Hi, this is the Science Chef. This video is a continuation of our solution to the May-June 2020 Cambridge IGCSE Chemistry Paper 4. Today we'll be answering question 4. If you'd like to watch our solutions to questions 1 to 3, we have added the links in the description. Question 4 says, this question is about reactions of bases and acids. Let's underline the keywords. Reactions of bases and what? Acids. We already know where the examiner is going. That's acid, bases, as well, and what? Salts. The first question says ammonia is a gas at room temperature. Okay. What is the test for ammonia gas? Describe the positive results of this test. Now, what do we know about ammonia? One, ammonia is a base. If ammonia is the only known alkaline gas, and for the fact that it's the only known alkaline gas, it means that it will turn moist red litmus paper what? Blue, right? So what's the test? Test using what? Moist red litmus paper. So what will happen? What will be the result? Red litmus paper turns what? Turns blue, to show that it's an alkaline what? Gas. And why must it be moist or damp? Because it is a gas. Without the moisture in the paper, it will not work. The gas will not have an effect on it. What happens there? The gas will dissolve, the ammonia will dissolve in the water in the paper to form what? Ammonium hydroxide, which will now act as the base on the litmus paper and turns it what? Blue, from red to what? Blue, right? According to this equation here. Can you see? According to this equation here, ammonia reacts with water to form ions. Yes, that's the equation that occurs when ammonia reacts with what? Moist red litmus paper. Okay, so ammonia reacts with water to form ions. According to that equation on the screen, ammonia and water giving us what? Ammonium ion and hydroxide ion. Take note of this reversible what? Arrows. This means that this is an incomplete what? This is an incomplete ionization, which means that ammonia is what? Is a weak what? Base. Fine. So how does this equation show that ammonia behaves as a what? Base? So let's look at this. Before the reaction, this was ammonia, right? And after the reaction, it turned to what? NH4. So from ammonia, from NH3 to NH4 plus, ammonia did what? Gained hydrogen what? Ion, is it not? From the water to form what? NH4 plus. And what is hydrogen ion? Hydrogen ion is what? It's called a proton, right? Wherever I say hydrogen ion or a proton, it means that you are dealing with what? With an acid, right? So if this is an acid and this is an acid and ammonia is a what? It's a base, right? So it means that ammonia as a base accepts what? A proton from the what? Acid, is it not? So you know that water is acting as an acid there, while ammonia is acting as a what? Base. So how does ammonia behave as a what? Base. It behaves as a base by accepting what? Accepting a what? A proton. Or you can say by what? As a proton acceptor. A base is a proton acceptor, while an acid is a proton donor. So in this reaction, water is acting as an acid because it donates proton, the hydrogen ion, to what? Ammonia, while ammonia acts as a base because it accepts what? The proton or the hydrogen ion from what? From water. Now, aqueous ammonia is described as a weak acid, of course, which we already stated. So just the pH of aqueous what? Ammonia. For weak acids, the pH of weak acid starts from what? Anything above what? 7, greater than what? 7, up to what? 11. So any value you pick from, let's say 8, from 8 to what? 11 will be what? Correct. So let's just take something in between. Let's say what? 10. If you write 8, you write 9, you write 10, 11, you will be what? Correct, because it's a what? A suggestion. Anything above 11 is what? Strong alkalinity. And that's when you have your sodium hydroxide, potassium hydroxide. Anything below 7 is what? Acidity. So describe what is seen when aqueous ammonia is added to aqueous copper 2 sulfate until no further change is seen. Describe what is seen when aqueous ammonia is added to aqueous copper 2 sulfate until no further change is seen. Now, the addition will start in drops, right? So when you add aqueous ammonia to aqueous copper 2 sulfate in drops, right? A pale blue precipitate, a pale blue gelatinous precipitate is formed, is seen when aqueous ammonia is added in drops then the precipitate dissolves in excess aqueous ammonia to give a deep blue solution, which is a confirmatory test for copper 2 ion. When you add ammonia in drops, to copper 2, to a solution of copper 2 ion, you see, or it forms a pale blue precipitate of copper 2 hydroxide. By the time you now add the aqueous ammonia in excess, the copper 2 hydroxide precipitate will now react with the excess ammonia to form a complex called what? Cu. This is beyond the IG scheme anyway. To form this complex, right? That is tetraamine copper 2 ion, which is seen as the what? As the deep blue solution. This complex is what? Soluble. It's soluble, right? It is not. It's always seen as the deep blue solution. So that's what actually what happened. The precipitate dissolved in excess aqueous ammonia to give what? A deep blue solution. Then the next question here says aqueous sodium hydroxide, right, is a strong alkali. Now it's a strong alkali that reacts with dilute sulfuric acid exothermically. Now what does that mean? That being a strong alkali, what happens? That it ionizes what? Completely. Ionizes completely in what? Solution, right? Completely in solution. Now we have sodium hydroxide, NaOH, aqueous, giving us what? Na plus, aqueous plus what? OH what? Minus. Unlike ammonia that had a reversible what? Arrows. This one is a one directional what? Arrow. Right? What type of reaction is this? That type of reaction between an acid and a what? And an alkali, or an acid and a what? Base. Remember, alkalis are soluble what? Bases. So when an acid and a base reacts, it forms what? Salt and what? Water. What type of reaction is that? That is what? A neutralization reaction. That's a neutralization reaction. Now complete the equation for the reaction between aqueous sodium hydroxide and dilute sulfuric acid. Now let's first of all break this down into ions, and H plus and SO4 2 minus. So there will be exchange of what? Radicals. This will pick up this, right? While this will pick up this, right? So this will now give us what? Na plus and SO4 2 minus plus what? H plus and OH what? Minus. So this H plus and OH minus will give us what? H2O. whereas this one will exchange radicals to give us Na2SO4. These two will come to sodium, while this one will come to what? SO4. So the compounds are what? Na2SO4 and what? H2O. And of course, that's why you have these two here to balance out this number of what? Sodium atoms. And then water here. Now let's look at this. Water, how many hydrogen atoms do we have here? 2 plus 2 here. That's 4. But we have only 2 here, so we multiply it by what? 2. Now oxygen. How many oxygen do we have? 4. 1 times 4, 4. Plus 2 times 1, 6. Right? That's 6. Here, 1 times 4, 4. Plus 2 times 1, 6. So it's balanced. We move. So before we solve the next question, you'd like to learn more about acid, bases and salts and neutralization reactions, you can watch our videos on acids, bases and salts, right? We have added the link in the description. The next question says, a student wanted to find the concentration of some dilute sulfuric acid by titration, right? The student found that 25 cm³ of 0.0400 mole per dm cube aqueous sodium hydroxide reacted exactly with 20.0 cm³ of aqueous sulfuric acid. Name a suitable indicator to use in this titration. Remember, at the beginning of this question, we were told that sodium hydroxide is a strong alkali which reacts with what? Dilute sulfuric acid. And dilute sulfuric acid is a strong acid, right? And being a strong acid, it means that for their titration, you will need any suitable indicator. You can use any suitable indicator, because at the end of the day, the end point will be around neutral. So a suitable indicator to use in this titration is what? Methyl orange, because it's a titration between a strong acid and a strong base. Now calculate the concentration of aqueous H2SO4 in moles per dm using the following steps first. So what are the steps? First, we have to calculate the number of moles of sodium hydroxide. Now what are we given in this question? We are given the volume of the base, which is 25 cm³. Then we are given the concentration of the base, which is 0.4 moles per dm, that's 0.4 molar, right? Then we're also given the volume of the acid, which is 20 cm³. Right now we have to calculate the concentration of the acid. Fine. Now how do we do that? First of all, we have to calculate the number of moles of the base sodium hydroxide in 25 cm³. Now to do this, we are going to use the formula number of moles equals to concentration of the base times volume in dm cube. So what's the concentration of the base given in the question? That's 0.04, not 0.4 mole over dm cube, then times 25 cm³. To convert 25 cm³ to dm cube, that will be 25 over 1000 dm cube. So this will cancel out this, and we are left with 0.04 times 25 all over 1000. That gives us 0.001 mole, right? So now that we know the number of moles of sodium hydroxide that reacted, what next? We are asked to do deduce the number of moles of H2SO4 that reacted with 25 cm³ of sodium hydroxide. So we are going to use this equation of reaction, right? From the equation of reaction here, the equation of reaction there, 2 moles of sodium hydroxide reacted with reacted with 1 mole of H2SO4, right? So which means that since the number of moles of sodium hydroxide in 25 cm³ is calculated as 0.001 mole, means that 0.001 mole of sodium hydroxide will react with X of H2SO4, and we solve for X here. Our X will be 1 times 0.001 all over 2. So that will give us what? 0.0005 moles of what? H2SO4. Means that for every 2 moles of sodium hydroxide that reacts, 1 mole of H2SO4 will be used up, right? So that's what the stoichiometry, that's what the mole ratio says. For every 2 mole of sodium hydroxide that reacts, 1 mole of H2SO4 will be used up. So if 0.001 mole of sodium hydroxide reacted, then half of that amount of H2SO4 will be what? Used up, which is 0.0005 mole. Fine. We are now asked to calculate what? The concentration of H2SO4, aqueous H2SO4 in moles per dm cube. Now to calculate the concentration, remember here we use this formula: number of moles equals to concentration in moles per dm cube times volume in dm cube, right? To calculate the number of moles. So we are going to use the same equation, but now making concentration as subject of what? Formula. So Ca here, we're going to use Ca equals to what? Number of moles over what? Volume in dm cube. So what's the number of moles that we calculated here? That's 0.0005 mole all over what is the volume of the acid? 20 cm cube. 20 cm cube in dm cube, that would be what? 20 over what? 1000 in what? Dm cube. So if this guy goes up, 1000 goes up, that was 0.5 over 20, which is 0.025 moles per dm cube. So the concentration of H2SO4 in moles per dm cube is 0.025 moles per dm cube. Right? So now as to calculate the concentration of 0.004 mole per dm cube of sodium hydroxide in grams per dm cube. Now concentration in grams per dm cube is what? Mass concentration, what we call mass concentration. And here mass concentration, which is concentration in grams per dm cube, is equal to what? Molar concentration, which is concentration in moles per dm cube, times what? Molar mass, times molar mass. So which means that the mass concentration of sodium hydroxide in moles per dm cube will be equal to what? Concentration in moles grams per dm cube equal to 0.04, right? 0.04 times the molar mass of sodium hydroxide. What's the molar mass of sodium hydroxide? This is 23 plus 16 plus 1, right? In grams per mole, right? This is moles per dm cube. So this was 0.04 times 40 times 40. Look, this moles per dm cube times grams per mole. If we evaluate this and this, we will go leaving us with what? Grams per dm cube. So 0.04 times 40 gives us 1.6 grams, 1.60 grams per dm cube. 1.60 grams per dm cube. Remember, when you're writing the concentration in moles per dm cube and grams per dm, you must always write them in what? In 3 significant word figures. So coming back, let's go through this step once again. This is a titration where you are using a known solution to determine the unknown concentration of another word solution. One of the solutions will be in a beaker, in a conical flask, while the other one will be in the word burette. The one in the burette is called the titrant, while the one in the conical flask is called the what? The analyte. So first off, from this question, we are looking for the concentration of the H2SO4, which means that the sodium hydroxide is the standard solution because its concentration is what? Known, and we are trying to use it to standardize the H2SO4. So first, what we do is, from the equation of reaction, you have to know the equation of reaction. from the equation of reaction, we know the mole ratio of the acid to base, or base to acid, as the case may be, right? Then from there, using the concentration of the base, now in this case the base is standard solution. Using the concentration and the volume of the base, we calculate the number of moles of the base that reacted, right? Which is 0.001 mole. This formula is used to calculate the number of moles of the solution, right? Number of moles of the substance in a solution. So it's concentration times volume in dm cube. So concentration of the base is 0.004 moles per dm cube, right? As given in the question here, right? 0.04 moles per dm cube as given in the question there. Then, and its volume is 25 cm cube, and we convert it to dm cube by dividing by 1000. 1000 cm cube make 1 dm cube. So if we evaluate that, we get 0.001 mole. Then from here, we are told to deduce the number of moles of H2SO4 that reacted with the 25 cm cube of the base. Now we can only do this using the mole ratio. Now from the mole ratio here, I said that 2 moles of the base reacted with 1 mole of the acid. It means that for every 2 mole of the base used up, right, 1 mole of the acid was used up, right? So since the amount that reacted now is actually 0.001 mole of the base, it means that half of that amount of the acid will be used up. It gives us 0.0005 mole. Then after that, we now use this number of moles here to calculate the concentration of the acid in moles per dm using this same formula, but now making the concentration the subject of formula, right? So since we are using calculate concentration of the acid, that's why we're making it Ca. So Ca equals to N over V, right? Good. N over V, right? So the number of moles, N is the number of moles that have been calculated here, while V is the volume of the acid, which is 20 cm cube converted to dm cube, which is why we are dividing by 1000, right? We evaluate this, we get 0.0250. Remember, this would be in bracket. So that's 0.0250. Then after that, we do we calculate the concentration of the 0.004 mole per dm cube. Based on this, we've answered this question already. Now we're told to calculate the concentration of H2SO4 in moles per dm cube using the following test. That is the concentration of the acid, right? We've done that. Now this is a different question. Here we are asked to calculate the concentration of the 0.04 mole per dm cube sodium hydroxide in grams per dm cube. Concentration in grams per dm cube is mass concentration, while concentration in moles per dm cube is molar concentration, and the relationship between the two is given as mass concentration in grams per dm cube equals to molar concentration in moles per dm cube times molar mass, because we can easily calculate the molar mass of the base. So now this gives by the time we substitute the values, the molar concentration or concentration in moles per dm cube of the base, which is 0.04, can calculate the molar mass of the base, which is 23. The relative atomic mass of sodium is 23, oxygen is 16, and hydrogen is 1. You can get all these values from your periodic table, right? So if we evaluate this, we have 0.04 times 40, which gives us 1.60 grams per dm cube. And that brings us to the end of question 4. So if you learned anything from this tutorial, like this video and drop your comment. Also, if this is your first time here, subscribe to our channel and turn on your notification bell to always stay updated with our new uploads. You can always join our membership club to gain access to exclusive videos, live chat rooms, and our live tutorials where you can ask questions on any challenging topic in chemistry and be rest assured that you will be answered. A wise man once said, "People that are hungry never give up." So stay hungry of your dreams till I see you when I'll see you.